In today's note, we are going to look at common factoring and factoring by grouping. So factoring is going to be a new concept for this course and new to grade 10. But factoring is the opposite of expanding. So in our last lessons, we've looked at expanding. We looked at expanding specifically binomials. But factoring is the opposite of expanding. So expanding, what that does, it basically allows you to write a product as a sum or a difference. So if we wanted to expand something, basically we're multiplying so that in the end, we're just basically having a sum or difference of terms, or we're adding or subtracting terms. So we see in the example here, 3 gets multiplied into both the x and the 2. So we've done multiplication and we end up with basically a sum. We have two terms added together. Factoring is going in the opposite direction. Right? So factoring basically allows you to write a sum or difference as a product. So here we're going backwards. So here we have a sum of two terms, and when we factor it, it becomes a multiplication or a product. So we go from 4x plus 8 to 4 times x plus 2 all in brackets. So basically we're kind of expanding something and making it larger, and then factoring to make it smaller. You could think of it that way. But basically they're just opposites. Common factoring is basically, again, the opposite of distributive property. So distributive property, remember we had a term outside the brackets that we would multiply through. Common factoring is the opposite, where we're taking that term that we multiplied through out and putting it back in front of the brackets. And so what we want to do when we're common factoring is we want to find the largest term that is common to all terms in the polynomial. For variables, so when we're looking at letters, you want to choose the lowest degree of the variable that is in all the terms. So if you look at the variable, if you have like an x squared or an x cubed, you basically want to choose the lowest degree of the variable that is in all the terms. Right? You want to make sure that it's included in all of them, and we'll look at some examples of that. For coefficients or numbers, choose the largest number that can divide easily into all coefficients. So you're looking for the largest number that can be divided into all the coefficients or all the numbers that are there. And this entire thing that that term that we come up with is called the greatest common factor, or GCF. So that is what we're looking for, and we'll see what we have to do with that. So in the first one, 4a minus 12. So in this case, I'm looking for the largest term that is common to both of these. Right? I'm going to look at the variables, and I want to choose the lowest degree, or basically the lowest exponent of the variable that's in all the terms. I can see that I have an a here, but there's no variable in the second one. So my greatest common factor is not going to have a variable because it's not common between the two terms. The coefficients, I'm going to look at the number. So what's the largest number that can divide both into 4 and 12? And if you think about it, you could think of multiplication tables. In this case, the greatest common factor is going to be 4. 4 is the largest number that can multiply into both 4 and 12. Now that I have my greatest common factor, I'm going to take that and kind of do the opposite of expanding. So that greatest common factor comes outside of the bracket, and then how do I figure out what's inside the bracket? Well, what do I have to multiply 4 by to get to 4a? In that case, it's just a. What do I have to multiply 4 by to get to negative 12? Or I can do negative 12 divided by 4. It's negative 3. So if I want to factor this product, or this difference of 4a minus 12, I'm going to factor it into 4 times a minus 3. And I should be able to see here that if I wanted to expand this, I would end up back with what I started with. So again, this is factoring, right? We're basically reversing or going back to distributive property. So I need to find what number would be outside of the bracket and then what would be inside the bracket. If I look at B, here I can, again, I'm going to look for this largest term or this greatest common factor, this GCF. So I have to look at what variable is common between both of them. In this case, I can see that there's a y that's common between both of them. They both have y's. So I know that my greatest common factor is going to have a y. Now I want to think about what's the largest number that can divide easily into both 8 and 20, or 8 and negative 20. Again, think about your multiplication tables. Think about what numbers multiply to give you 8, what numbers multiply to give you 20, and you should come up with 4. 4 is the largest number that will divide easily into both of these. 8 can be divided by 4, negative 20 can be divided by 4. There's nothing higher. Now that I know my greatest common factor, that's going to go outside of my bracket. Because again, we want to turn this back into basically a distributive property type question. So the greatest common factor is going to go back outside the brackets. And now I need to figure out what goes inside that bracket. There's different ways you can think about it. You can think about, okay, what does 4y have to multiply by to get to 8xy? Or you can do 8xy divided by 4y, and that answer is going to be the first part of your bracket. In this case, it's going to be 2x. Then to figure out the second part, well, what do I have to multiply 4y by to get to negative 20y? Or you could think of negative 20y divided by 4y. You would get negative 5. So this now is factored. I've taken a difference and I've turned it into a product or multiplication. Or I've basically gone from a expanded form back into a factored form or a distributive property type question. If I look at C, C is a little bit more complicated because I have quite a few things going on here. But again, let's just start with looking at the variables. What variable is common between all three terms? And again, a term is what is separated by a plus or a minus sign. So there is one term, there is another term, and there is a third term. So I want to figure out what is my greatest, or what variables are common between all of these. In this case, they all have x's and y's. So I know my greatest common factor is going to have at least an x and a y. Now I have to look and see what is the lowest degree that is in all terms, or what is the lowest exponent that is in all of them. If I look at the x's, we have x squared, x to the power of 4, x squared. So the lowest one in this case is x squared. So that's going to be an x squared. And if I look at the y's, I see y squared, y cubed. The lowest degree or the lowest exponent is 2. So that is what my variables are going to be for the greatest common factor. Now I need to look at the coefficients. What is the largest number that can be divided into 3, negative 8, and 12? And if you think about it, the largest number that can divide into all of those is only going to be 1. So I could put a 1 here, or I don't have to. It's up to you. But my greatest common factor, let me just move this closer, is going to be x squared, y squared. So now that I know what my greatest common factor is, when I factor, that's going to go on the outside of my brackets, and now I need to know what goes inside. So I can divide every term by this greatest common factor. So 3x squared y cubed divided by this, 3 stays the same, or 3 divided by 1 is 3. The x squareds cancel out, and I'm left with a y. So it is going to be important to remember your product and quotient rules. Right? Remember, if you're dividing powers with the same base, you subtract the exponents. So the next one, we have -8, and then x to the power of 4 divided by x squared, or the exponent's 4 minus 2 is 2. Y squared divided by y squared cancels out. And then lastly, 12 divided by 1 is 12. X squareds cancel out, y squareds cancel out when you divide, so I'm left with just 12. And now this is factored because it is basically now a product. And if you're unsure, you can distribute this property or multiply this x squared, y squared through to the bracket. Right? You can multiply this through, and you should then return back to that original answer, or that original expression that you started with, if you factored it properly. So you can always check to make sure that you've done it properly by just expanding or using the distributive property and seeing if you get back to the original question. In D, I'm going to look for my greatest common factor. So I'm going to look between all the terms. I don't see a variable that is common between all of them, so my greatest common factor is not going to have a variable. So now I'm looking for the numbers. In this case, an easy way to figure this out is start with your smallest number. In this case, I have 3. So I know that my largest number that can divide easily into all of these has to be at the highest 3. So does 3 divide into all of these? Yes, it does. So I know my greatest common factor will be 3. So 3 is going to go outside the brackets. Inside, we're going to divide each of these terms by 3, or basically, like said before, do the opposite of the opposite of expanding. So instead of multiplying, we're dividing. So -27x squared divided by 3 is -9x squared, minus 9x divided by 3, or -9x divided by 3 is -3x. And then 3 divided by 3 is +1. And this is my factored form. You could also look at the bracket, and if you're unsure if you factored it fully, is there a larger number that can be divided, or a larger variable that can be divided into any of these 3 terms? In this case, there's not, so we've gone as far as we can go. In E, again, let's look at the variables first. In this case, they both have x's, so I know there's going to be at least an x. And now I want to look for what is the largest, or sorry, the smallest degree, or the smallest exponent. So 3 and 5. So I know that it has to be 3. That's the smallest one. And now I'm going to look for the numbers. What's the largest number that can divide both into -5 and 10? In this case, it would be 5. Now, you may be asking, why do I do 5? Do I do -5? In the last example, you could have thought the same thing when we had the 3. General rule of thumb, you may want to start with, make sure the first term is always positive. So in this case, you may want to do -5 instead of just 5. So in the last one, we may have wanted to do -3 instead as well. So let's do -5x cubed. That's my greatest common factor. And if I look at each of these terms, I need to divide them by -5x cubed. So in the first one, it's the exact same thing, so they cancel out or become 1. And then 10 divided by -5 is -2. X to the power of 5 divided by x to the power of 3. Subtract your exponents, and you get x squared. So that is your factored form. For F, Again, look for the greatest common factor. Look at the variables. Do they have one in common? Yes, in this case they have p that's in common. Now look at the exponents. What is the smallest exponent out of all three of them? In this case it's 3, so my exponent has to be 3 on the p. Next we're going to look at the numbers. What is the largest number that can divide evenly into all of these coefficients? Easy way to do it, again, is look at the lowest number and think about what numbers can divide into 6. Right, so we have 6 and 1 and 3 and 2. Well, 6 can divide easily into 12, but it won't divide into 8. 3 can divide into 12, but it won't divide into 8, so that only leaves me with 2. So the largest number that can divide into all three of these is going to be 2. So I know what my greatest common factor is. That's going to go outside my bracket. And inside, I need to divide each of these three original terms by this greatest common factor. So 12 divided by 2 is 6. P to the power of 4 divided by p to the power of 3 is just p, or p to the power of 1. Negative 8 divided by 2 is negative 4. P to the power of 3 divided by p to the power of 3 cancels out completely. And then I have 6 divided by 2, which is 3. P to the power of 5 divided by p to the power of 3 is p to the power of 2, or 5 minus 3, which gives me the power of 2. And this is my factored form. So I've factored as much as I can. There's nothing that will divide into all three of these terms in the bracket, so I've gone as far as I can go. G, again, same idea. Look for that greatest common factor. Start with the variables. So if I look, there's D's in all of them. There's a C in one, but there's no C's in any of the other ones. So the only variable that I can use is going to be D. Next, we're going to look at what is the lowest degree, or what is the lowest exponent on D. And I see 2, 3, nothing, or an invisible 1. And then 4. So the lowest one in this case is 1. So that's going to be my exponent. So I'm not going to actually show it because I don't need to. We assume it's 1 if we don't see an exponent. And next, I'm going to look at the variable, or the coefficients. Look at the numbers. What is the largest number that's going to go into both, or into all of these terms? And in this case, again, you want to start with the lowest number. So if I start with negative 8 or 8, what numbers can divide nicely into 8? Well, I have 8 and 1, 2 and 4. 8 can divide nicely into 16 and 24, but not 28, so that doesn't work. 4 can divide nicely into 8, 16, 24, and 28. So that's the largest number that's going to work, so I'm going to use 4. So I know my greatest common factor is 4D, so that's going to go outside of the bracket. Now to figure out what goes inside, I need to divide every term by that greatest common factor. So I need to divide 4D by, negative 8D squared by 4D. So if we divide the numbers, negative 8 divided by 4 is negative 2. D squared divided by D is just D. Negative 16 divided by 4 is negative 4. We divide the D's, we get D squared. 24 divided by 4, we get 6. So positive 6. C stays there. And then D to the power of 1 divided by D cancels out. And then negative 28 divided by 4 is negative 7. D to the power of 4 divided by D, or 4 minus 1, gives me an exponent of 3. So this is my factored form. So it is quite long, but we can see that if I look at these terms inside the bracket, there's nothing I can divide it further by. Another type of factoring that we could do is factor by grouping. And in order to factor by grouping, you must have an even number of terms. Because what we're going to be looking for is we're going to be looking for something common between all the terms that we have in our expression. So if I look at the first example, 5x times x minus 2 minus 3 times x minus 2. In this case, x minus 2 is common to both terms. If I look at this, both terms have an x minus 2. So x minus 2 is going to be my greatest common factor. So my greatest common factor is the entire bracket x minus 2. So if I take x minus 2 out and put that in front, what remains? Or if I divide it out, what remains? And in this case, an easy way to do it is see, okay, what is left? In this case, I have 5x and I have minus 3. So that is all that's remaining inside the bracket. So this is my factored form now. In B is a little different, but I should see some things that are kind of similar. And what we see here, if I look at the first two terms and the last two terms, I do see some things in common. I can common factor the first part. They both share an a. So I'm going to factor out an a and be left with x minus y. In the next part, I can see a negative 5 or a 5. And I'm going to factor that out, and I'm going to be left with x minus y. And the reason we're doing negative 5 is because if I took out, if the greatest common factor in this second half was positive 5, then I would get plus 5x, or I get minus x plus y, which isn't going to help me with a factor by grouping. So you kind of have to recognize that there is going to be some factoring by grouping. So you need to see, how can I get this second bracket to match the first one? So that's why we're taking out the negative, or negative 5x, because that will change the sign in the second bracket. But here, hopefully we can see now that it's very similar to the first one. Both of these terms share this x minus y bracket. So x minus y is going to come out in front. And then what remains? Well, it's just these two terms in front, or a minus 5. In C, again, we're going to do the same thing. We're going to look at each part separately. If I look at the first part, is there anything that I can common factor here? Well, 10x squared plus 5x. Here, the greatest common factor for the red part. The greatest variable is x. The greatest coefficient is 5. So I'm going to have 5x on the outside, and inside 2x plus 1. Because we're factoring by grouping, we want to see, okay, is there something similar that I can do in the second bracket to get so that when I factor, I'm left with one part as 2x plus 1. So if I look at the second one, for the greatest common factor, well, I can see that I can take out at least a y. And if I look at the coefficients, I can see that I can take out, in this case, a minus 3. That's the greatest coefficient, so minus 3y is my greatest common factor. Inside the bracket, I'm left with 2x plus 1. And again, if you took out a positive 3 instead, you would see that in this bracket, it would be very similar to the other one, except the signs would be different. So then you can go back and factor out a negative of that greatest common factor instead. Now, I can factor by grouping because I do have the same bracket that's common. So in the third one, the third greatest common factor, and so this is why we're color coding. is going to be the whole bracket of 2x plus 1. So that's going to come out. And what remains are the two things that we're multiplying by that. So 5x and then minus 3y. In our last example, D, this one's a little bit long. What we want to do first in this case, the first thing you should always be doing is common factoring. So you want to always look for a common factor. That's the first thing that you should always be doing, is look for a common factor. So in this case, if I look at all these terms, is there a number or is there a variable that's common between all of them? There is no variable between all of them, but there is a number, right? All of these numbers can be divided by 2. So if I wanted to rewrite this or factor out 2, I would get 3mx plus 3my plus 2x plus 2y. So I've common factored out a 2. Let me just give myself a little bit more space here. Now what I want to do is I want to factor this by grouping. I want to see, is there anything I can do in certain parts? And what we can see, or what we will try to start to see, is if I look at each two parts individually, the 2 is going to stay there. If I look at the 3mx plus 3my, there is a common factor there. The greatest common factor for this part, or what's common between these two terms, is 3m. We can see 3m in both of them. So in the first part, my greatest common factor is 3m. So when I factor that out, I get x plus y. And in the second part, I can see that I have a common factor of 2. So it's going to be plus 2 and then x plus y. And then finally, we should be able to see that we can factor by grouping again, because both of these two terms have the common bracket of x plus y. So basically there's lots of greatest common factors in different steps. And when we break this down, the x plus y is the one bracket, and then what remains is the 3m plus 2. And that is our final factored form. And again, if you're unsure, you can always go back and you can expand this, and we should make our way back up to that original expression. So lastly, we want to write an expression for the area of the shaded figure as a polynomial, and then write the factored form. So in this case, the area of the shaded figure, so again, we want to find the total area, which is length times width. So in this case, x plus 3 times x plus 7. We want to find the area of the unshaded, length times width, or x times x. And that's where we're going to start. So the total area, if we expand this, so going back to the last lesson, get x squared plus 3x, or sorry, keep this in common, plus 7x plus 3x plus 21. Combine our like terms, we get x squared plus 7x, or sorry, plus 10x plus 21. And that's our full area. Our second area, if we have x squared, or sorry, x times x, we get x squared. And if we want to find the area of the shaded figure, we have to subtract the 2. So x squared plus 10x plus 21, all minus x squared. So we get 10x plus 21. And now we want to write this bottom part, because this is my area, in factored form. Can I factor this? Well, let's look. Is there a common variable between them? Nope, there's not. Is there a common term or coefficient between them? Is there a number that multiplies into both 10 and 21 nicely or evenly? And there is not. So this is already in factored form. So even though it says write in factored form, it already has been, because I can't simplify that any further. So I know there's a lot here, but again, the largest thing or the biggest thing idea that you're trying to do is get your greatest common factor. So what is the variable? Is there a variable that is common between all terms? If there is, look for the lowest degree or exponent. And is there a coefficient or number that can be divided into all of the terms? If so, what is the largest number? That's going to be your greatest common factor. We can go back up, we can see that here. That's going to be your greatest common factor. And then you have to take that and basically do the opposite of distributive property. Place the greatest common factor outside of your brackets and divide every term in the original expression by that GCF, and that's going to go in your brackets. So it is a new concept. It might take some time, but go through it slowly and look for that GCF or greatest common factor first.